Hey there, boys and girls. Today we are going to assess reasonableness of fraction sums and differences. So we have done this all year, seeing how reasonable our answer is. And we are talking about when we are adding. The answer is when we add and subtract fractions. Okay? So we'll be able to do this with like and unlike denominators. We know how to find a common denominator and figure out if our answer is reasonable. So our first problem says, Jamie is building a bird feeder. He connects two metal rods together to make a stand. The blueprint for the project shows the length of the rods. What is the total length? So if we look here at our picture, we can see that this section is 1/6 of a yard. This section is 2/3 of a yard. A says write an expression to model the situation. Remember, an expression is a number sentence without an equal sign. So if we're going to put them together to make a stand, then we would be adding those fractions. Now, find a common denominator for the fractions in this expression. So we have been practicing and working on this. Probably there's one coming right to your mind. I always like to look at the largest number and then think, when I'm counting by threes, do I say 6? Yes, I sure do. So 6 could be a common denominator. Write equivalent fractions using those. Since this fraction 1/6 already has 6, we don't need to change it. But 2/3, if I had 2/3, and I'll stick it up here, and I was changing it to 6, I know that it took 2 of those to give me 6, so 2 of these, 4/6 will be equivalent to 2/3. Remember, 6 are going to be smaller than thirds. So I'll have 1/6 plus 4/6. Okay, then it says write an expression using fractions with a common denominator, then find the total length of the rods. So just like we said, 1/6 plus 4/6 equals 5/6. How do we know our answer is reasonable? So let's think about that. How do we know that our answer is reasonable? Okay, we could have estimated. 2/3 is almost 1. Almost 1. And 1/6 is really close to 0. So 1 plus 0 equals 1, and 5/6 is close to 1. Now there may be other things that you did to assess the reasonableness, but rounding those, like we talked about last week, to benchmark fractions, 0, a half, or a whole, can be very helpful. Okay, let's keep on rolling. I'm so sorry, that was page 153. Okay, let's look at page 154. We're still using, our bird feeder. Jamie fastens the bottom of the bird feeder to the pole. He has 4 boards that are each 5/6 foot long. How much must Jamie cut from each board to make each side of the feeder 3/4 long? Okay, so we see that he has fastened the bottom of the bird feeder to the pole. And he has 4 boards that are 5/6 foot long, but he needs them to be 3/4 foot long. So in expression, remember, they are 5/6. We need them to be 3/4. So we're going to subtract those amounts to find out how much he needs to cut. Let's write an expression using fractions with a common denominator. All right, so let's think about our 6 and our 4. And you know, we've used our tiles, we've used our cutouts that we made. Again, I kind of look at the bigger number, 6, 12, 18. I could even write them right here. If we're counting by 4s, 4, 8, 12, 16, and I see that they have 12 in common. Not the only one, okay? You might be thinking of a bigger number, 24, because you say 20 and then 24. You could also use that. That's still going to give you that same value. It's just written as a different fraction. So let's use 12. So I like to show mine over here. 5 6 minus 3 fourths. I want mine to be 12, my common denominator. I know that 6 times 2 is 12, so 5 times 2 is 10. That's helping me stay equivalent. I did the same thing to the numerator and the denominator. 4 times 3 is 12, so 3 times 3 is 9. So right here, write an expression using them with a common denominator. 10 twelfths minus 9 twelfths. How much should he cut? Well, when we work that out, we get 1/12. How do we know if that's reasonable? Again, if we're using our benchmark fractions, 5 6 is almost a whole, kind of equal to a whole. 3 fourths is close to a whole. So 1 minus 1 gives you that 0. 1/12 is really close to 0. Because it is not very much that he's having to cut off of that pole. Let's look at these two at the bottom. For these 3. Jamie starts with 7/8 ounce of glue. After a project, 1/4 ounce of glue is left. Write an expression that can be used to find how much glue he uses. Solve the problem and show that your answer is reasonable. Alright, he starts with 7/8 ounce. We'll write him over here. When he's done, there's 1/4 left. I want to find out how much he uses. Okay, let's think about this and eating it easier. If I had 8 donuts and I ate some and 4 were left, you would know that I subtracted, or that I ate 4. Now, one way to get that could be 8 minus 4. So I know that I'm going to be subtracting these, but I need to first make them equivalent fractions. Make equivalent fractions so they have a common denominator. Can also see what's going to make sense to me. Alright, let's think about 7/8 and 1/4. So I would say 7/8 is pretty close to 1. 1/4 you could say is close to 0 or close to a half, because it's right there in the middle of them. So somewhere about a half or smaller is what I'll say. Okay, this common denominator probably comes to your mind very easily. We've worked with these a lot. 8. We know we're counting, we say 4, 8. So we will keep 7/8, and 1/4 is equivalent to 2/8, which gives us 5/8 as our answer. 5/8 is close to our 1/2. And so that helps us to know that our answer is reasonable. He had 7/8 and he had 1/4 left. Okay. Oh, up here I should have said 1/4, 1/2 or higher. All right, 2/3 minus 1/5. Right here, there's no word problem. We're just going to do the job it takes to answer that. We're looking at thirds and fifths. A denominator they have in common is 15. I'm going to rewrite it down here. So 2/3 is equivalent to how many 15ths? 3 times 5 is 15. 2 times 5 is 10. 1/5 would be 3/15. Because I'm going to make sure that I'm doing the same thing with the numerator and denominator. So 10 minus 3 is 7/15. Okay, now we have 1/6 and 3/4. We already used these numbers and we chose 12 last time we had 6 and 4. We're adding this time. 1/6 we know is 2/12. 6 times 2 is 12. 1 times 2 is 2. 3/4 would be how many 12ths? 4 times 3 is 12, so 3 times 3 is 9. That gives us 11/12, which is almost a whole. But you know, 3/4 is almost a whole, so if we add something to it, that's going to help it make sense. Okay? Now, boys and girls, there are several more problems y'all can keep working on. Make sure you do your homework for today and do your best.